All right, the notes today are covering sine and cosine functions, what the graphs look like. We will actually not do a lot with sine and cosine. More important is just looking at the periodic function and what that looks like on a graph and labeling pieces of it. So the first thing is that whenever you have a function that repeats at regular intervals, okay, so it's repeating, it's called a periodic function. Periodic function. Periodic functions are going to have three characteristics that we will refer back to as we're working through the notes. Okay, so three things that we'll basically focus on today. First one is the period, and it's the horizontal distance for the graph to complete one repetition. Okay, so basically we want to find the starting and stopping, so it's a horizontal distance to complete one repetition. We want to see where it starts and stops. So this is like the distance from the max to max or min to min is another way to think of it. So the distance from the max to another max or a min to a min. And it'll make more sense once we actually go through and do an example. The midline is the horizontal distance that is in the middle of the graph, okay? The horizontal axis, I think I said distance earlier, that's the middle of the graph. And this is always going to be a y equals line. So some kind of line that basically cuts the graph in half, kind of like an axis of symmetry, but going the other direction. And then lastly, the amplitude is the height of the graph. And here it says half the difference between the min and the max. But there's a little bit easier way to do this. Instead of half the distance, basically just find the distance of the max or the min. Okay, and again, this is like the height of our graph. And so I'm going to try to use the same color combination here as we work through the graph. So anytime I'm using blue, we'll be referring to the period or how far it takes from one repetition of the graph or one cycle. The midline will be the line that cuts the graph into two pieces, one on top, one on bottom, and the amplitude, the distance of the max or the min. So the first examples basically are just trying to figure out, is it a periodic function? So if it's a periodic function, it should have repetition. So looking at the graphs, we can clearly see that this first one definitely has repetition. It looks the same. Whereas the second one, we've got different hills and valleys, different lengths. So one way that we generally do this is we look at the start of the height. So here's a height and here's a height. If we connect them, this distance, is that going to be the same as this distance? Okay, and you could easily just count the distance. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So both of these have a distance of 8. So it means they're periodic because they're going to start over again and have the same amount of space. Here, we would say here's a height and here's a height. We don't have the same distance as we go through. They do not match up. They must come back up to the original max and come back down to the original min in order for it to be periodic. So because this one always starts up here, every time we know the next one will be up here, it cannot change. This one is not doing that same pattern. Okay. So the examples on homework are going to look more like example 2. So we're going to determine the period, the midline, and the amplitude for each of these functions. And like I said, I'll be using this color combination throughout to kind of go through it. So again, the period is how long it takes the graph to go through one full repetition or one cycle. So basically, if we take the height, here's the height, and here's the other height, we find this distance. Okay, or you could find the minimums as well. So here's a minimum and here's a minimum. Now, the only thing is, when you go to find this distance, you're going to notice these values, pi over 2 and 5 pi over 2, those are not very nice numbers, okay? Not to say that you can't use them, but they're not super nice. So in order to find the distance from here to here, we're basically going to do subtraction. So you do 5 pi over 2 minus pi over 2. So the bigger distance, or the bigger value minus the smaller value, will give us this overall length. And that's going to give you 4 pi over 2, which is just 2 pi. Another way to think of period, because this can be kind of confusing and sometimes you don't have nice values, like you might also be hitting halfway between a point, and that's a really hard distance to find. So another way is just to think about starting the graph. So let's say my graph starts here. I'm going to cover up this piece. I want to know when this starts over again. So this is all new. And then here I'm starting that same curve again. So if I were to look at just this box of it, okay, because I'm starting here and then it repeats and it starts over again, this would be one period, what I just boxed in this greenish color. And the distance is from 0 to 2 pi, still getting the same answer. So that's another way when the period is a little bit hard with the fractions. Just try to find the distance of starting to stopping before it repeats the cycle again. Hopefully that makes sense. The midline is the horizontal line that basically cuts the graph into two. So thinking about this line here, this is what it looks like it's going to be. That line, half the graph is above it and half the graph is below it, okay? And it must be equal, and you just want to tell me what this value is. It's y equals 0 because we're at the x-axis. So the midline will be y equals 0. And again, it's just the line. So if we were to fold this piece over, it should land on the minimum value here. And then the amplitude is the height of the graph, or the min. So I can use this distance here, or I can use, let me come over here, this distance here. Doesn't matter. Amplitude is just one of these. So from here, I'm at 0, and then I go up and I'm at 1. So this has a height of 1. And then if I do the minimum, because these should be the same, if they're not the same, it's not a periodic function. If I go here, I'm at 0, and then I'm at -1, so the distance again is still 1. So my amplitude is just 1. And that's basically how you do these. So I'm going to go ahead and pause so the video doesn't get too long, and then I'll do 2 more examples.